The last section of chapter 4 is about inequalities in triangles. So the first thing that we're going to talk about is something called the triangle inequality theorem. And what that theorem states is that the sum of the lengths of two sides of a triangle is greater than the length of the third side. So in other words, again, if I label the entire side A, B, and C in the pictures below, if I take side A and side B and add them together, that sum has to be greater than the length of side C. Not only does that inequality need to hold true, but then if I add the length of side B plus side C, that has to be greater than the length of side A. And again, my third one would be if I add side A plus side C, that length combined has to be greater than the length of side B. All three of those must hold true. So our first example, we want to determine if the following sides could form a triangle. So again, I'm just going to start adding two sides and seeing if it's greater than the third. So the first one that I'll do is 2 plus 3 is greater than 8. 2 plus 3 is 5, and immediately, since 5 is not greater than 8, the answer would be no for part A. For part B, I'm going to do first 8 plus 17, and I need to know if that's greater than 24. 8 plus 17 is 25, and 25 is greater than 24. So the first inequality holds true. So again, I need all three inequalities to hold true. So I just had 24 over on the right-hand side. So how about we put that 17 over on the right-hand side now? So if I do 8 plus 24, I need to know if that's greater than 17. And 8 plus 24 is 32. And 32 is greater than 17. So again, that one holds true. And then the last one that I'll need over on that right-hand side is that 8. So now I need to know if 17 plus 24 is greater than 8. And 17 plus 24 is 41. And 41 is greater than 8. So since all three inequalities hold true, the answer is yes, those could be the sides of a triangle. For part C, let's do 3 plus 3. And the first thing I want to know is that greater than 6? So if I add 3 plus 3, I'm going to get 6. And 6 is not greater than 6. It's equal to 6. And since there is no greater than or equal to symbol here, the answer will be no. So here's a real world example of when you could use this. Okay, so how could you find the possible lengths of the third side of a triangle given two sides? So we're going to build a triangular sandbox, and two sides must measure 2 and 5 feet. And we want to find the range of all the possible lengths of the third side. So again, if I draw a picture of what's going on here, again, doesn't have to be to scale or anything like that. So one side has to be 2, one side has to be 5, and I'm looking for that third side. Okay, so all I'm going to do is write 3 inequalities and see what happens. Again, the sum of two sides has to be greater than the third. So the first thing I'm going to do is add 2 plus 5 and set that greater than x. I'm going to write all 3 inequalities before I start to solve them and talk about them here. The next one that I'm going to do, again, I had x over on the right-hand side of that inequality. How about we put the 5 over on the right-hand side of the inequality? So if I do x plus 2, that one's going to have to be greater than 5. And your third inequality is going to be x plus 5 has to be greater than 2. Okay, I want x on one side of my inequality, and I want just one number on the other side of the inequality. So when I am looking at the first inequality with 2 plus 5 is greater than x, 2 plus 5 is 7, and 7 is greater than x. You have your variable on one side, you have your number on the other side. That's great. Okay, and I like my variable on the left-hand side, and it's going to help me write a compound inequality in a second. So if I want to flip this inequality, again, I'm just going to interchange the x and the 7. And just remember, the alligator is eating the 7 in the inequality that's right here. So when I flip this, I'm going to have to flip that inequality symbol. So these two things, again, are exactly the same. So this is the one I'm concerned about right now. So x is going to be less than 7. For my middle inequality, I'm going to subtract 2 from both sides to get the variable on one side and a number on the right. So I have x is greater than 3. And just like in the problem before, the x is already on the left-hand side, so I don't need to flip it or do anything fancy here. And then if I try to solve this third inequality, 2 minus 5 is greater than -3. If we're talking about building a sandbox, you can't possibly have a negative length for a sandbox. So anytime that you get an inequality that has a negative in it, you're going to ignore it. Okay, so I'm concerned about these two inequalities now. Okay, and now I want to write a compound inequality. When you write a compound inequality, your variable is always going to go in the middle, and you're always going to have two less than symbols on either side. The smaller of your two numbers is going to have to come on the left, and the larger of your two numbers is going to have to come on the right. So between 7 and 3, the smaller number there is 3. So 3 is going to go on the left, and 7 is the larger, so 7 is going to go on the right. So your inequality that you're going to have in the end is 3 is less than x, which is less than 7. Okay, and then for number 3, we're going to have the same thing here. An isosceles triangle has sides 2 and 12, and we want to know how long the third side can be. So again, draw a picture of what's going on here. So I have isosceles triangle has sides 2 and 12, and I want to find my third side. Okay, now here's the thing. Here's something that you have to know. The sides of an isosceles triangle has two congruent sides. So there's only one option here. X either has to be 2 or x has to be 12. There is no other option, again, because it's isosceles. So let's say I start with the number 2. So I have one side is 2, I'm going to assume another side is 2, and then I have 12. So if I do 2 plus 2, that needs to be greater than 12. Last time I checked, 4 was not greater than 12. So I think what's going to happen here is we're going to have to use the 12 instead. So now if I did 2 plus 12, that would have to be greater than 12, and 14 is greater than 12. There's really only two inequalities here because it doesn't matter if I interchange the 12 and that 12, it's still going to be the same thing. Right, so the only other thing that I can have over on that right-hand side then would be the 2. So if I do 12 plus 12, that has to be greater than 2, and 24 is greater than 2. So yep, 12 is your only option there. So because it's isosceles, you had to choose between it being either 2 or 12, and then we just had to make sure which inequality worked. Okay, we can also order angles and sides. So the deal with the angles is that the smallest angle is always opposite the shortest side, and the largest is opposite the longest. And vice versa, you could do the same thing with the sides. The shortest side is always opposite the smallest angle, or the longest is opposite the largest. So in the triangle on the left, I have triangle ABC, and I have side AB is 4, side AC is 5, and BC is 6. So if I want the largest angle of that triangle, the first thing I'm going to do is look for the largest side, which is 6. And the angle directly opposite that is angle A. That's how I got A is the largest. Okay, and then for my smallest, if I look for my smallest number here, between 4, 5, and 6, it's 4. And if I go directly opposite that side, that's angle C. So angle C is going to be the smallest angle. I didn't ask about it, but B would be in between them. Okay, and again, if I gave you angles instead, so 3 angles of a triangle, I have 54, 75, and 51. And the first thing that I'm going to do is look for the longest side. So if I'm looking for the longest side, I need to find the largest angle. That's the one that's denoted by the 75. And if I go directly opposite that angle, side AC is the side directly opposite angle B. So that means that AC is going to be the longest side. Shortest side, I'm looking for my smallest angle. My smallest angle here is 51. And again, that arrow is already drawn in there. Directly opposite that is going to be side AB. So AB is your shortest side. So could you find the shortest side of a triangle when given only 2 angles? So let's see. So I have angle A is 70 degrees, angle B is 30 degrees, and we want to name the shortest side of triangle ABC. Again, to me, it's always easier to do these problems if you have a picture of what's going on. And again, it can be any old triangle. It does not need to be accurate. It just needs to be able to help you to answer the question. So I was told that A was 70 and B was 30. Well, the first thing I'm going to do is I'm going to find the measure of angle C just so I know which angle, how many degrees are in each angle of that triangle, and I can then accurately find the shortest side of the triangle. So the first thing that we'll do is we'll find that angle. All three angles need to add up to 180. So if I take x plus 70 plus 30 has to equal 180, or x plus 100 has to equal 180. Subtract 100 from both sides, and x is going to equal 80. So angle C is going to equal 80. So I need the shortest side of triangle ABC. So that's going to be across from the smallest angle. So your smallest angle there is 30. Directly opposite that is going to be side AC. Okay, so in the end, we didn't even need this information, but it's just nice to know what all your angles are, because what if that was the shortest, the smallest angle? For number 5, we have an isosceles triangle ABC with AB is 6 and BC is 3. What is the smallest angle of the triangle? Okay, so again, I'm going to draw an isosceles triangle. Again, any old triangle will do, and we'll label it A, B, and C. So AB is 6 and BC is 3. And again, the first thing that I want to do is I want to find the length of AC so that I know how to find which angle is going to be the smallest. So the third side there, just like we did a few slides ago, there's only two options here. If it's isosceles, you have to have two congruent sides. So that side AC either has to be 3 or 6. And again, if I use my triangle inequality theorem, if I assumed that it was 3, I would have to have 3 plus 3 is greater than 6, and 6 is not greater than 6. So that does not work. So it can't be 3, which means AC has to be 6. So if I want the smallest angle, that's going to be opposite the smallest side. So my smallest side here is the one that's 3, and the angle directly opposite that is going to be angle A. Okay, and then our last one for number 6, if we have angle D is greater than angle F and angle F is greater than angle E, what is the shortest side of triangle DEF? Okay, so again, I'm going to draw a triangle, and I'll call it triangle DEF. Okay, for me, it's always helpful if I have numbers. Do you absolutely have to have numbers for this one? Absolutely not. But for me, it's always easiest to have numbers for my angles. So I'm going to make up some angle measures that are going to make these these two inequalities, but to find the 3 angles that make those 2 inequalities hold true. But just keep in mind, in the end, all 3 of your angles need to add up to 180. So I'm going to try to keep my math real simple here. Okay, so the first thing I need angle D is greater than angle F. So I'm going to call angle D 80. So if angle D is greater than angle F is going to have to be less than 80 degrees. Let's subtract 20. So let's make that 60. Okay, that would make the third angle of my triangle. X plus 80 plus 60 equals 180. Or X plus, oops, that's supposed to be a plus. I'm sorry. X plus 140 equals 180, subtract 140. That would make my third angle 40. Okay, so again, we forced D to be greater than F when I picked out 80 and 60. So now let's see if this holds true. Is angle F greater than angle E? Is 60 greater than 40? And it is. Okay, so now we can go ahead and answer what the shortest side of that triangle is. Again, you could have picked any angle measures to start. Again, just keep in mind they need to add up to 180, and you need both these inequalities to hold true. And did I need to pick out numbers? No, you probably just could have thought about it logically to figure out which of your sides had to be bigger, and figured out which side was the shortest as well, and or which angle was the smallest, and therefore which side is the shortest. So shortest side is across from the smallest angle, so your smallest angle here is 40. The side directly opposite that is DF.